Hi students, I'm going to record the hints for your assignment 1 for you. Okay, so for question 1, 1A is very simple, so I'm going to 1B. So for 1B, what you need to know is that for 1 mole of titanium 3 chloride, okay, if you don't know what is titanium 3 chloride, what is the oxidation state of titanium in TiCl3, you can look at the question. So titanium 3 chloride, these 3 will tell you that Ti is plus 3, the oxidation state. Okay, and therefore 1 mole of TiCl3 will give you 1 mole of Ti3 plus how many moles of Cl minus. So since there is these 3 over here, you will know that it is 3 Cl minus. Okay, and since 1 mole of TiCl3 gives you 3 moles of Cl minus, now the question gives you 0.5 mole of TiCl3. So how many moles of Cl minus would it produce? And then the question wants you to calculate the number of chloride ions. So wherever it is number, it is asking you to calculate the number of particles. So you need to remember that 1 mole of any substance, any species is equals to 6.02 times 10 to the power of 23 particles. So now, based on the mole ratio, you calculate the number of moles of Cl minus first, then after that calculate the number of Cl minus in that TiCl3. Okay, for question 2 and 3 is very simple, so I'm not going to go through that. But for question 4, okay, this is an example of a data response type of question, but it's sort of a simpler kind of data response question in this case. Okay, so the question is about acrylamide, which is this compound over here, C3H5NO, and is believed to be carcinogenic. So if you read on, it says that a person can safely ingest up to 0.5 milligram per kg body weight per day without any adverse effects. Then, given that 1 kg of brewed coffee contains 1.2 times 10 to the power negative 7 mole of acrylamide, calculate the maximum volume of coffee a 50 kilogram woman can drink per day. Alright? Wherever you have, you need to calculate the volume of a substance, most likely you may require the density. Okay, so in this case, the question tells you to assume that coffee has the same density as water. So, if you do not already know, the density of water is 1 gram per cm cube. Okay, 1 gram per cm cube. Density is equals to mass over volume. So water has a density of 1 gram per cm cube. So now they ask you to assume that coffee has the same density as water, so coffee also has the density of 1 gram per cm cube. So based on this, and based on the information, number 1, you should know that for in order to find the maximum volume of coffee, and since you need to use density, you will need to know the maximum mass of coffee, okay, because the density is 1 gram per cm cube, so cm cube is actually the volume, okay, and grams is the mass. So since you need to calculate the maximum volume of coffee, you need to know the maximum mass of coffee that a 50 kilogram woman can drink per day. Okay, and if I'm you, the first thing that I will link the information out in this question will be this: the 0.5 milligram per kg body weight and this 50 kilogram woman, because body weight means the weight of a person. So this is the only way to link the two information up. Alright, and from here I can actually calculate the maximum, okay, from the highlighted information I can calculate the maximum mass of acrylamide. Okay, this 0.5 milligram is 0.5 milligram of acrylamide per kg body weight of a person. Okay, maximum mass of acrylamide which is this MR over here, I mean this molecular formula, that a 50 kilogram woman can ingest is equals to something. These two information, you see how you can work it out together, since the units is given milligram per kg over here, and over here is kg. So if you want to find the mass, what multiply by what or what divide by what, you go and figure out. Okay, it will give you information A. Alright, next, from the 1 kg of brewed coffee contains 1.2 times 10 to the power -7 mole of acrylamide, you will be able to find the maximum mass of acrylamide in 1 kg coffee. Correct? Okay, so from the amount given, of acrylamide and from the molar mass of acrylamide that you can calculate, you should be able to calculate the maximum mass of acrylamide in 1 kg coffee. So this one will be B. Alright, and based on A and B, you should then be able to find the maximum mass of coffee that a 50 kilogram woman can ingest. Alright, so based on A and B, you can find the maximum mass of coffee that a 50 kilogram woman can ingest. Alright, then after that, that will be this mass over here. So that's the maximum mass of coffee a 50 kilogram woman can ingest, and then using this density 1 gram per cm cube, using this density, you will then be able to find the maximum volume of coffee that woman, a 50 kilogram woman, can ingest per day. Alright, so since you have the maximum mass, which is in grams, and you have the density, which is grams per cm cube, you think whether you should multiply these two things together or divide these two things together such that your units will be cm cube and your grams will be cancelled out. Alright, so that will be question number 4. Question 5 is very similar to your tutorial question C2, so I'm not going to go through it, but you just have to take note that in this case it's H2SO4 and not HCl. So H2SO4 is a dibasic acid, so when it reacts with NaOH, the mole ratio is not 1:1. So please take note when you write out the balance equation and when you find the amount of excess H2SO4. Okay, so that's all for assignment 1.